In this lesson, we're going to discuss what happens to duration and convexity measures when analyzing not single bonds, but a whole portfolio of fixed income instruments. And there's more than one approach to computing portfolio duration and convexity. It would be ideal if we could aggregate the cash flows from the different bonds and build them into a cash flow profile for the whole portfolio and calculate Macaulay duration that way. Although that is not really feasible, for sure not in the CFA exam. So we will use a more practical approach, and this is what your book goes into. In order to compute portfolio duration and convexity, we shall use weighted averages of the durations and the convexities of the individual bonds constituting the portfolio. And when it comes to the weights, we will be weighing things by market value, which is important because there may be let's say a propensity to use par values. Don't do that, use market values of the individual bonds. Now, the benefit of doing this is that it is practical. A lot of people use this, out of real life bond fund managers do this. However, please be aware of the drawback of this approach. It assumes that when interest rates change, when yields change, there is a parallel shift in the yield curve. So basically, if you imagine this being a yield curve, and this obviously being the time to maturity, okay, these are rates. A parallel shift means that all across this term structure of rates, they kind of move up or indeed down by exactly the same amount. So the shape of the curve remains the same. And that's not really very realistic, because in reality, when interest rates change, they don't change by or they very rarely change by the same amount everywhere on the yield curve. The yield curve may become steeper, meaning long-term rates change more than short-terms, or it may become flatter, which would suggest the opposite thing. There are different ways in which the yield curve changes, and it rarely does so in this parallel shift way, up or down. Nevertheless, that's a limitation you should be aware of, but it shouldn't stop you from applying this method or this approach if you are asked to perform such computations in the exam. So here's a question I made up, or I created, based very much inspired by what is in your book. I had a look at a couple of the questions and I kind of got the best out of them, I think. A bond portfolio consists of two bonds, and we have bonds X and Y with equal par value. So the amount of money in terms of par value invested is the same across the two bonds, but the bonds have two different prices, which will mean that their market values are not the same. And we have annual modified duration and annual or annualized convexity for both bonds, so we don't need to calculate that individually for the bonds. And now, for a 50 basis points drop in the yield to maturity, and using weighted average duration and convexity, the expected price change for the portfolio is closest to. In other words, what will happen to the value of the portfolio if yields drop by 50 basis points, by half a percentage point. Okay, this is what we have to analyze, and we're assuming this happens kind of uniformly across the yield curve. Right. The first thing we need to do, step one, is to calculate the weights. Okay, so let me do this here. Step one, calculate the weights. In order to calculate weights, I need to actually get my head around the market values. So we've got bond X here and bond Y, The amount of investment is exactly the same across the two bonds. It's 10 million. Actually, because it's 10 million uniformly, I don't necessarily need that 10 million here, but I'll do it properly. I'm multiplying now by the price. Now this is obviously per 100 of par value, so I'm multiplying this by 0.935, which is going to give, I guess, a market value for this first bond, bond X, of $9,350,000. Do the same for bond Y. It is trading slightly above par with a premium 101.24. So times 1.0124 to reveal a market value of 10,124,000. So what I need now is the total value of the portfolio, so as to get the weights, the proportions. 935,000 plus 10,124,000. Okay, the total value of the portfolio in market terms is 19,474,000. And now for those all important weights, I will check what's the weight of this in the overall portfolio. So 9,350, okay, I'm omitting the 3 zeros at the end, divided by 19.474, and I get 0.48. So this is, I guess, 48%. Whoops. Wrong pen here, 48%, and I guess that means the other one should be 52. Let's just check. 10,124, omitting the 3 zeros at the end, divided by 19,474. Okay, that is indeed 52%, so the total does is 100% as it should be. I could have just summed these two prices, and because the par values are the same across the two bonds, you could have checked what the sum of the par prices is, and then calculated the weight of each price in the sum. That would have given the same weights. Right. What I need now, so that was my step 1, calculate the weights. I shall now proceed to what I will call step 2, and that will be computing the weighted average duration and the weighted average convexity. So weighted average duration first. Take the durations for each of the bonds, 13.3 and 8.42 respectively, and weigh by the weights that we just discovered over there, 48% and 52. Okay, the first one was 13.3%. Sorry, not 13.3. The duration was 13.3. I'm going to multiply that by the first weight for bond X, so 0.48, and then the second duration was in fact 8.42, and I'll now utilize the second weight, that's 52%. Let's see what this gives. 13.3 times 0.48 plus 8.42 times 0.52. Okay, 10.76. Okay, that's a 10, sorry. 10.76. Do the same with respect to the weighted average convexity. So let's take the right numbers. 44.25 for the first one, 44.25 times the weight, same weight as above, 48%. Now the second convexity measure was for bond Y 23.82, 23.82 times a weight of 52, so 4425 times 0.48 plus 2382 times 0.52. Right, the weighted average is 33.63. Good. Now, we've got the weighted durations and the weighted convexity, so now step 3 is going to be to actually calculate the impact on the price of the bond. After all, that's what we were asked about. For a 50 basis points drop in the yield to maturity, kind of the whole curve, and using weighted average duration and convexity, the expected price change for the portfolio is closest to. Right, well, let's utilize the same formulas as we did before. So the percentage change in the full price of a bond, and this also goes for the portfolio, is going to be given by negative modified duration minus modified duration times the change in yield. So here I'm going to use the weighted average duration but make it negative, minus 10.76 times the prescribed change in yield, which was 50 basis points. Once again, be very careful about how you go about, writing this down in decimal format. 50 basis points, so 0.5%. It's a drop we're interested in. Okay, so minus 0.005. That's 50 basis points. If I went further, it would be 5 basis points if I went to the fourth place after the dot. And now I'm going to add, just like I would with the formula for a single instrument, 1/2, so half times the convexity measure, which is 33.63 in this case, and multiplied by the change in yield, but squared. Okay, it's a negative change, but it doesn't really matter because squaring will get rid of the sign. This should be it. This should be the expression. So let's see what we get. Let me deal with what's in the square bracket first. So starting with the 0.005, squaring this, okay, multiply by 33.63, dividing by half, so effectively multiplying by 1/2, and now adding what I have on the left hand, well, not on the left hand side, but here to the left. I can see that both numbers that I'm multiplying out here have minuses in front of them, so I'll get a positive result. So I'm just going to drop the minuses. 10.76 times 0.005. Let's see. Okay, I get an answer of 5.42%. So this is in percent. It's a positive number, 5.42. Let's check that against the possible answers to this problem. Yes, it is absolutely in line with answer C. In fact, I think 538 would be what you would get if you only did the modified duration computation, and obviously the convexity adjustment makes the increase in the price a little bit higher, increasing the value a little bit higher. 554, answer A, is what you'd get if you applied the adjustment the wrong way around, deducting it instead of adding.